Okay, the last example of roots of complex numbers. Solve the equation z to the power of 5 equals minus root 3 plus I. As you can see straight away, we know we're going to get 5 roots, and which will be equally spaced starting at z1. And also we notice that minus root 3 plus I is not real. So roots don't come in conjugate pairs like example 2 did, but also the sum of the roots will equal to 0. Okay, so let's confirm that. That's what we just talked about. And also it's going to be equally spaced. It'll form the vertices of the regular pentagon because there's 5 roots. So example 2, we had 4 roots equally spaced, so it was a square. But this one will be pentagon. Okay, always step 1 will be find the location of z1, and then we're going to say z1 equals r brackets cos theta plus I sine theta. And of course we need to use the left hand side and right hand side with that, just very similar to what we did in example 2. So left hand side, let's have a look at that. It'll be, we need to write it in a polar form. So it'll be like that, and by de Moivre's theorem, it will look like this. And then right hand side, now right hand side is not real, and also we need to find a modulus and argument on that one. And just remember, this is in a third quadrant, okay? The minus and plus is a third quadrant, because we will need to think about that when we have to do argument. So I'm going to find modulus, which I think symbol we commonly use is r, is square root of a squared plus b squared, which is, this is a, and b is 1, okay? So when I do that, I'll get 2. Now argument here is the tan theta over b over a, which is b is 1, a is minus root 3. Now I'll get minus pi over 6, but it's in the second quadrant. Oh, sorry. So this is wrong. It's a second mistake. Second quadrant. It does make sense because if you look at it, second quadrant, the x-axis is negative, y-axis is positive. So it's a second quadrant. Now when it's a second quadrant, you need to put 5 pi over 6, which is just, so that was minus pi over 6. And to form the pi, I said the other side is a 5 pi over 6. So that's a positive. When it goes anti-clockwise, a positive, clockwise a negative. And they both have to go pi. Okay, so remember that. Okay, so going to the next one. So right hand side, we done it because the modulus was 2, argument was 5 pi over 6. Now we'll put them equal and equating. Let's put it on there. So I'll equate it r to the power of 5 equals 2. 5 theta equals 5 pi over 6. Now if I do that, I will get r equals really 2 to the power of 1 over 5th. And it looks like that. And the 5 theta equals 5 pi over 6. And theta equals pi over 6 because I'm times by 1 over 5th. Okay, so therefore my z1 is this. Now, because the other 4 roots will be equally spaced from z1, I'm dividing 2 pi by 5, so it'll be spaced out by 2 pi over 5. So my second root will be like this, because I'm just adding the 2 pi over 5. Now we'll get that. And the third one, again, I'm just adding 2 pi over 5 onto each, and I will get this. So far, not a problem, because 29 pi over 30 is also, it's in the second quadrant. It's quite safe if it's a first and second quadrant. If it passes to second to third, that's when we have to use a principal argument and make it into negative. Okay, so for example here, when we do 29 pi over 30 plus 2 pi over 5, now it's gone over, okay, over the pi. So we need to bring it back. So using the principal argument, and I just diagrams a little bit here. It's going to push this one. Yep, that's better. So I've got 41 pi over 30 going all the way up to here, and that part is the way how much is past the pi, which is 11 pi over 30, because 41 pi take away 30 pi is 11 pi. Now to form the 30 degrees, so it'll be minus 19 pi over 30, and then if I didn't have that minus, I will form the 30 pi over 30. Okay, so my fourth roots are like this. Okay, so now we have to look at the fifth one. Let's have a look at the fifth one. So I'm just adding 2 pi over 5 from the fourth root, and I will get that. And then 5 roots are, these are all 5 roots. Now to sketch all this on the Argand diagram, I found it's easier if I could just do some degrees on it. The same as example 2 as well, if you want to find out how well it's spaced out. Just write a little degrees on the side. Pi over 6 is 30, 17 pi over 30 is 102, and then you can sort of visualize where the points are. Okay, so little notes here. The conjugate pairs, there's no conjugate pairs, as you can see from all the 5 roots, because minus root 3 plus I is not real. But if you actually put it all in a calculator, for example, cos all this, you will get 0 in your calculator, same as a sine. So the sum of the roots, all 5 roots, equal to 0. Okay, let's have a look at some diagrams here. Now this one is the z to the power 5 equals minus root 3 plus 1 I, which is coordinates of minus root 3 comma 1, which is something like that. That is 5 pi over 6. And I'm going to put all 5 roots on the Argand diagram, and it'll form a regular pentagon. Okay, so with the z1, our argument was pi over 6, and it's spaced it out to pi over 5 because it's the 5 parts. So you do 2 pi over 5, and for the z to the power 5, it was from the start to the where the z to the power 5 will be, the argument will be 5 pi over 6. So it's good to actually put all the information in one, and make sure you use pencil if you need to, and produce a neat and big diagram, big enough to see.